All right, so let's look at example 7b now. And it's going to be similar. We're going to do kind of the similar thing here as we did before. So this is y equals logarithm base 5 now of x plus 2. Okay, so what's the transformation that's going on here? Well, this has to do with h, right? So since I'm looking at the opposite of h, what does this mean? This means that I'm going to move everything to the left, or in the -2 direction, left 2 or -2. So everything shifts to the left 2. All right, so just like before, to figure out the points on this, I'm going to look at just, first of all, I'm not going to look at the transformation. I'm just going to be looking at y equals log base 5 of x. And I'm going to start again by just finding some points from its inverse, the exponential function, y equals 5 to the x. And getting those points, and then I'm going to reverse the domain and the range, and then I'll plot those, and then put the shift to the left in there. All right, so I'm going to just pick, because these numbers get so big so fast. So when x is equal to -1, 5 to the -1, that's what, 1/5, right? I put 0 in here, I get 1, and to the first power, I get 5, right? If I put 2 in there, I'm looking at, I'm looking at 25 already. Okay, so that just off the screen. If I put -2 in there, I'm looking at 1/25, okay, which is getting really close to the x-axis. All right, so the inverse, so that's going to be y equals log base 5 of x. Okay, so here's the untransformed function. I'm just going to swap my x's and y's here. So my y's here become my x's. So my input's 1/5, 1, 5. I can put 25 in here. It's not going to be on the screen. And then my output, or my range of my logarithmic function, is the same thing as the domain of my exponential function. So that's -1, 0, 1, 2. All right, so I'm going to plot these points, and then I'm going to do the transformation, and then I'll sketch the graph. So when x is 1/5, okay, again, I'm just, I'm just sort of like pretending like I can figure that out. So I'm kind of over here. When x is 1, I'm at 0. When x is 5, it's 1, 2, 3, 4. 1, 2, 3, I'll get 1, 2, 3, 4, 5. Okay, then y is 1. Okay, and then 25 is like off the screen, and y is 2. So this thing's going to be kind of sort of flat doing this. And this is going to come right straight close down like this. Okay, and I shouldn't have drawn that. All right, so that's the untransformed function, right? So now I'm going to shift everything, okay, because this is a shift to the left of -2. So that means that this point here is going -2 this way. Okay, and then this is going to go -2 over here, and then this is going to go -2, 1, 2 this way. And so now my graph is going to look more like this. It should be kind of more like that. Okay, so anyway, this is a sketch, okay, so it's hard to do these things exact. So there it is. All right, so now let's take a look at the effect that this has like on our domain and range. All right, so remember we said we had a vertical asymptote at x equals h, and h in this case is what? H, remember this is minus h, so x equals h is x equal -2, right? So I have a vertical asymptote at this line. Okay, so it's going to get real close to this line, but it doesn't cross it. Okay, and now, so that means what's my domain? My domain then, all the values of x have to be to the right of this asymptote, right? So my domain is going to be x has got to be greater than -2. All right, what about the range? Are all my y values represented? Yes, they are, because these arrows are going to go forever and ever, and eventually, and there's not going to be any breaks in it, and any place that I cross the y-axis, I should be able to hit this graph. So my range is going to be all reals. All right. All right, last thing we're going to do is example 8. at the bottom of page 489. Okay, so example 8, and basically you're going to be using the function that you came up with from example 4, where we said that S, the slope of the sand, remember that one? 0.159 plus 0.118 common log base 10 of D, I guess the diameter of the sand, and it says we're going to use the graph to estimate the average diameter of the sand particles for a beach whose slope is 0.2. All right, so I am going to cheat a little bit and give you the window to help you, because we're going to graph this. Obviously, this is going to be y equals 0.159 plus 0.118 log x. Your window, I want your x min to equal 0. X max is going to equal 10. X scale is going to equal 1. Y min is going to equal 0. Y max is going to equal 0.5. Y scale is going to equal 0.1. Okay, so I want you to graph that function and take a look at it. And you should get something that's kind of similar to what you see in the book. It should be pretty close. And so the question they have is they want us to estimate the average diameter of the sand particles for a beach whose slope is 0.2. So in other words, and so this is going to go into y sub 1, and then in y sub 2, you're going to graph 0.2, y sub 2 equals 0.2, and then you're going to use your intersection feature to figure out what the diameter is going to be given the slope. And so you're going to do, after you graph, you're going to hit second, calc, and then you're going to hit intersect curve 1, curve 2, guess, press enter, and you should get D, again I was going to say X, equals 2.225, and I think the book is rounding this up to 2.23 millimeters for that. All right, that is it for this lesson. It's a pretty hefty lesson. If you need any help or anything like that, please reach out to me and I will help you with this section. Thank you. Talk to you soon.